Hey guys, what's up? Eddie Aho here with KissAnalog.com. Owon sent out this meter, so we're going to take a look at it. It's a clamp-on. This one's pretty interesting. It's a high count clamp-on, so it's kind of like a higher-end Owon clamp-on. They've got a series of them, I guess. Anyway, this one's one of their higher-end ones, if not the highest end that they have. It's the CM2100B. So we're going to take a look inside it. We're going to take some measurements, and yeah, we're going to see what we think about this. Okay, this came packaged in a bigger box, well protected. So it's box in a box, and but yeah, we're going to come over and see what you get and take some measurements. We're going to take a look inside as well. All right, guys. So here's the box. Okay, just pretty plain Jane, which is nice that they don't spend a lot of money on the box. And there's the model number right there. It's interesting that the way they spell Bluetooth. But yeah, so here's the mother company. Okay, that's who owns Owon, from what I understand, and of course made in China, like most things are. So all right, so when you power on, you'll get the APO, the automatic power off, and I believe you can hold down this button. Let's try it. And then it's off. So, but it seems like you can hold either one of these buttons down when you turn it on, and the APO will be off. And right now the Bluetooth's trying to connect. Okay, so right now I have a 100K ohm resistor in there. Just want to kind of show you what, some of these ranges, what they look like. So you got 2 digits, a period, and 2 digits. Okay, and that's using one of these well, you can see the accuracy, 0.025%. And what's nice is I always like to check to see if the spacing between these are, the standard spacing, which they are. So that's really great. Here's a 10K, so we'll just see what the value looks like there. And so now we got 3 digits passed here. So we're under 20,000, so that's why we get the 3 digits. So now we go all the way out here. It's 0.5% plus 10 counts. So that means the last 2 digits can change up to 10 counts. Okay, so that's the typical accuracy, but you can see this is like, pretty darn close to 10K, right? Okay, I'll put a 100 ohm resistor in here. Okay, so that was the 10K. Okay, now we'll try this 100 ohm. So you can see a smaller ohm value. And also I'm kind of showing you in the different ranges how long it takes to settle in, just so you can kind of see, how long it takes for a high count meter to settle in. So there's the 100 ohms right there. Okay, now we're going to try a small value, a 10 ohm. Okay, and there we go. So remember, it's 10 counts. So those last 2 digits can change up to 10 counts. All right. So, the other thing, just point out, there's an off on both ends. So if you're down here reading ohms, you can just go to here to go off. So yeah, you can go either way. The other thing I want to point out is that, well, here, let's just go up here. Voltage is DC by default, and then you have to do the select for AC, okay? So now current is the opposite. So I find that kind of interesting. I'm almost surprised that all of them aren't AC, by default, just because this kind of meter, a lot of times you're doing AC stuff. Now here on the bench, if I'm using this on the bench, which I'd be doing a lot with the small currents, I might want these to default to DC. Now, there are some high-end meters that when you select a range and then you turn off the meter and you go back to that function, it'll go to the default where you left it the last time you used it. There's not a lot of meters that do that. I actually like that, because that way, if you're commonly using, say, DC current, then you don't have to, hit the button every time. But It's not a big deal. It's just something to remember, you know, and so you can see the display, DC or AC, okay? And again, AC, you got the variable frequency. So you got the high frequency filter for the AC readings, both current and voltage, okay? Well, here, let's make sure you can do it for current. Actually, I'm not positive about that. Yeah. So VFC. So yeah. So okay. So you get the filter for both current and voltage. Okay. That's when you're doing variable frequency drives or anything where noisy environment where you need some filtering. All right. All right, guys. Just want to show you the bag it comes with. It's kind of a canvasy kind of a bag, and what I like is it's not just barely big enough to fit the meter. There's some room in there. Full-size test leads wrapped up, and the manual's, you know, pretty good size manual for a little meter like this. And it came with a little screwdriver to change your battery, which that's pretty nice because, you know, if you're out in the field, you need a battery, and yeah, it'd probably be good to carry a second, like maybe rechargeable battery in here. And just give you an idea of the manual. So they do talk about the Bluetooth functionality, and they show you some different screens. So yeah, you know, just typical manual, right? But if you want to look at the specifications, 0.7% for DC voltage, that's really good. And 0.8% for AC voltage. And then for DC current, you got 2%, and AC current is 3% at the low range or 2.5 at the higher range. So there's your specs if you want to take a look at those. And one thing to point out, it is 3 times a second, which is really nice for, you know, low cost meter. All right. It also does come with the PVC leads. It has the kind where, you know, the real grippy things on the terminals here, so that's always nice. And this is kind of a hard plastic. It almost looks like soft rubber here and hard here, but it's got a little bit of texture here, a little softer, and up here it's a little harder, but nice long sharp tips. And yes, they do come with these protective caps, which I usually take off. They're good so you don't short things. They're good for, you know, 1 kV. You know, usually Cat 3, Cat 4 type stuff. So by the way, this is rated for Cat 3. They're not trying to say it's a Cat 4 device. So it's Cat 3, but it is 300 volts at Cat 3 and 600 for Cat 2. So it's nice that they're not exaggerating the rating. So I like that. All right, so one thing I want to point out on leads is they're good for 10 amps, but you're not going to be putting current through them because you have the jaws here. So you know, that's the way you read current with a clamp on, right? But these are just general purpose leads, and so that's why they have that. And also the ratings up here on the cap, you always want these for Cat 3 and Cat 4, these little caps, okay? So, but this meter is only a Cat 3, right? We talked about that. It's 600 or 300 volts for Cat 3 and 600 for Cat 2. So the probes are rated for 1,000 volts Cat 3, or was that 600 volts for Cat 4. So they're rated well over what the meter's capable of. Now, they're not the most flexible leads, but they're not the stiffest either. I think we know what brand sells the stiffest leads. But anyway, they're not the most flexible leads. So it'd be nice to maybe get some silicone leads. I've shown some where you can get, you know, some of my favorite leads are only $10, or yeah, I don't know if the price has changed, but they're right around $10. All right, you know, I thought, hey, we should just read something boring like AC voltage, right? So I've got my leads back. Let's put these on here, and there we go. 120. Well, if I stop moving this around, oh, it's on DC. You know, that looked like it defaulted to DC, which is unusual because on current, it defaults to AC. So, yeah, 102 volts. I'll move the voltage around. Yeah, you can see it reacts pretty quick. I'm just moving the dial on my volt box over here. So there we go. And let's see if we go to frequency, hertz. Oh, there's 60 hertz. That looks right. And let's go duty cycle. 50% duty cycle sounds right. I just turned off the power. There we go. All right, guys. I got a big 10 millifarad cap, so let's try to read that. I have the backlight on to help out, but I don't know if you can see it. Might make it harder to pump current into this capacitor. I think the most meters come out around, 9 millifarad. That's about right. That wasn't actually too long either, right? That was not bad. All right, I got a little small cap here just to show you that it can do small capacitors as well. And yep, 22 nanofarad is what it is. And if I can hold these leads on there. All right, guys, in continuity mode, it is pretty fast, right? And it is pretty loud. So, yeah, not overly loud, but loud enough. All right, guys, I got a bridge rectifier here, and in diode mode, it does give you the voltage readout, but you notice there's no beep, right? And okay, I've turned it off, I've powered down, and I've unscrewed the cap with the screwdriver they provided, which was a nice touch. Now, one thing that's nice about this is the screw is retained, so you're not going to lose it. That's awesome. I love that. And then it also has the metal insert. So just want to point out those things. And then it looks like we have 2 more screws to take it apart, but I just want to show you the battery compartment. And yes, I do use the batteries that come with it. I hate that people just immediately throw them away. It's like, come on, get some use out of them and don't just throw them in the trash until you use them, right? So look at that. There's no circuit board. If the batteries did leak, hopefully it'd be protected from damaging the board. So that's also a nice touch. Again, this blue color is all rubberized. Nice feel to it. I'm going to get a bigger screwdriver to take off these. So I have this set, which I really like. I've kind of shown a video on this thing, but this is great. I'm going to put a link down below if you guys want to get one. But I think it's a knockoff of another brand that costs a lot more money. But anyway, they work nice. And then they pop out like that. So, but yeah, I'm going to go ahead and pull these off and I'll get back to you. Okay, I'm going to carefully pull this up. First of all, let me get these screws and put those somewhere safe. Okay, and then, all right, that came off pretty easy. There's the battery power terminals right here. They come down and touch the board right here. And there's a bunch of ribbing on this thing. Here's the little post that this gets screwed into, and the other one is screwed into this. So this little structure across here is going to basically act like an electrical block or whatever else debris that wants to come in here. This is going to, those little plastic stoppers are coming up against this, so that'll keep things clean inside the board. We see our Bluetooth module, and we have our, looks like a little PTC right here. And there's the crystal oscillator. It looks like 4 megahertz running this IC here. And we've got a couple more ICs. Let's see if we can get a close-up of this. There's actually 3 potentiometers. Interesting when you see that these days for calibration. You know, so often. Well, and that's probably because of this. You know, setting the coil up and all that. It's not like a chip with a resistor on a normal multimeter. You know, with the clamp-ons, there's going to be some tolerance into this, and I'm imagining that's what those 3 pots are for. And here's a little ribbon, flexible cable right there. That's a nice touch. And it looks like I'm imagining this little black wire right here, it comes to the board right here. That's probably for the non-contact voltage reading. So yeah, looks like a nice, clean, laid out board. I do not see any aluminum electrolytic capacitors, which is a nice touch. I see just small ceramics, so we don't have to worry about aluminum caps. Now here's a tantalum cap, that little yellow chip down there. So yeah, it looks like a nice design. All right, guys, so what I've done is I've shorted my power supply leads together, okay? And I'm gonna, I'm pulling actually 1 amp. I've got 1 amp set up on my power supply. So it looks like, let's see, if I come out here and zero it off, then put that on there. Yeah, so it's reading just over 1 amp. Okay, so I want to go down and see how low of a reading we can get, okay? So let me set that. Okay, I'm at 0.8 amps, so there's 0.7, 0.6, go down to 0.1, okay? Now what I'm going to do is, let me just reset this to 0 again. Okay, it looks like it is zeroed out. Just want to make sure. Okay, and I'm putting this like basically in the center of the jaw there. So we're about 0.1, okay? So depending on where, you place this in the jaw, you can get a little bit different readings. So you want to place it towards the center if you can. Some of these things, like there's actually a little arrow right here and a little arrow right there, okay? And so it's telling you to put the wire kind of in that, between those arrows for the best reading. Okay, so I'm going to basically do that. Okay, and we're about, I've got it set for 0.1 and it's just a little bit higher than that. So let's keep on working on this. Okay, I'm going to, let's see, let's go to 0.01. So there's 10 milliamps and it's saying 24. So it's off a little bit. Now I'm at 0.02 and it's still off, 0.03. Let's go down 0.01 again. And, after reading the higher current, okay, it looks like it's zeroed out. I just want to make sure. I want to see how low of a current we can read. I'm at 0.01 and this is, so I mean, the accuracy is going to be pretty iffy down here at the low current levels. You can see that right now, right? Let me go back to, okay, there's 0.02, 0.03, 0.04. Looks like it's starting to dial in. I'm at 0.05, 0.06. And that last digit, like in any meter, is the most unreliable. So 0.06. Okay, there's 0.07, 0.08, 0.09. So yeah, okay. And now I'm at 110, which we're getting pretty close. So it seems like when you're up around 100 milliamps, you're getting a lot better or more accurate readings. So I just wanted to see, how low you could read on this and what the accuracy would be. And looking at the manual here, it says that at the 2 amp range, it says 1 milliamp resolution, but that's, I don't know about that. But it does say plus or minus 2% plus 8 digits. Okay, so that means that last one can move plus minus 8, and also we have 0.2%, and also we have the 2% tolerance. So 100 milliamps, it should be about 102 or something, but then that says 8 digits, so that could be 2% plus the 8, which would be 110, I think. But let's just see if this is zeroed out again. So see, it's 0.0, it's 6 digits, 2 digits right there. We'll just zero it out again. Yeah, so there we go. So at 100 milliamps, you're starting to get, close to the tolerance. But yeah, I think that's about where you can really count on accurate readings. All right, guys, Bluetooth mode worked pretty easy. Just hooked right up, and when I move the dial here, you see it affects that over there. And let's see if I go to different selections, capacitance, voltage, diode. Yeah, so pretty cool. You can change it here or at your meter. So, and one thing to point out, which I forgot before, is VFC. So it has that filter for the high frequency stuff, on your AC line. So that's nice. So let's go to voltage again. And we'll go to, we're on DC, we're going to go to AC. And let's see if we can select that VFC thing. Oh yeah, there we go. So I just hold it down, it goes to VFC, and it says it right up here. And so, got the backlight on. So yeah, this is pretty nice. All right, so then I can start to record a record, and I can set up intervals and record counts. So that's all pretty cool stuff. Okay, I can do my light and select here. I can 0 meter, select here. So pretty cool. Okay, when I'm in this start record page, I go record intervals and counts. And then down here, I guess I start, oh, it says no devices connected. Did I disconnect my Bluetooth? Not sure what's going on there. All right, it looked like I was just disconnected, but here's the data and here's my graph. So it's showing the graph, and here's a chart. You can read the file, you can save it, pull it back. So yeah, it looks like a pretty nice little app. I mean, it's kind of amazing you get these free Bluetooth apps with devices like this now. So you can go clamp this on something, maybe you're going to look at the current into a battery that's out in the cold, and you want to come in and just see how it's going, so that's pretty cool. Hey guys, so what do you think of the meter? Nice little meter, has a good feel to it. I like that they send this bag out. That's really great. This is the kind of thing that you might stick in your glove box or in your toolbox, and so having a case to protect it's really nice. Measuring current, just by clamping on instead of breaking the circuit. It's so nice to be able to do that. A lot of times whenever I do electrical work or whatever, I'm grabbing a clamp on. But here at the bench, with the clamp on like this that has a small range, the 2 amp and 20 amp range, that's going to be very useful here at the bench for a lot of things I do. So really like that. 20,000 counts, that's really nice too. Giving those extra digits, because those last digits, when you look at the accuracy of a multimeter, they'll give you the tolerance, like say 0.5%, but then it'll say plus 8 digits or whatever, or it might be 10 digits. So 8 digits would be that last digit would go up and down 8 counts. So, you really don't want to count on that last digit. And if it's a 10 count or a 13 or 15 count, the last 2 digits can change up and down 15 counts. So, yeah. So anyway, that's why it's nice to have a high count meter, because you can count on the digits closer to the decimal point, right? So anyway, there you go. Hey, I want to give 2 big thumbs up to Owon for sending that out to me. I've got a couple others coming, and then I'll do that shootout review and kind of compare all the different meters, clamp-ons. But yeah, 2 big thumbs up to my patrons. Really appreciate you guys. You become a patron for as little as $1 a month. Links down below. And 2 big thumbs up for, I think, 3 members of my channel. So there's a member button down below. There's also that super thank you button. And 2 big thumbs up to the guys that have hit that super thank you button. Really appreciate you guys. So yeah, thanks Owon for sending this out to me. There's a couple meters. There's one I'm probably going to have to buy. I think one is from KPS that they're going to send me, and yeah, but I think there's one I'm going to have to buy. And then I think I'll have a really good assortment of clamp-ons to do a shootout. Okay, so look for that. Hey, a free way to support the channel is use those links down below. I've got codes for a lot of them. I'm going to see if I have a code for this discount code, but I got discount codes. But even if it doesn't have a discount code, it doesn't cost you anything extra to use it. Just supports the channel. So thanks, appreciate that. And a free way to support, another free way to support the channel is just hit the like button. Hit the little thumbs up. That really helps a lot. Share it, comment, leave your comments, tell me what you think. And yeah, that'd be great. You may notice, if you haven't watched my reviews before, that I don't do a lot of measurements, and I don't say I have calibrated devices, even though I do have some pretty precision type stuff, because I've never seen a meter review. And let me know if you've seen one. The thing was out of calibration, or it didn't meet the specs. And a lot of times when those measurements are being taken by people that say they had calibrated sources that they bought off or they built, whatever. Anyway, I just think it's a waste of time personally, because I haven't seen a meter that's been out of spec. So let me know if I'm wrong, if you've seen a review where a meter didn't meet spec. I mean, yeah, so that's why I don't do that. I try to show what the meter are doing, what it looks like, and how fast it changes, and how fast it captures numbers and things like that. Things that I think are valuable and help you select one meter over another one, versus just doing a bunch of measurements that are kind of meaningless. But anyway, let me know what you guys think, okay? Thanks for watching. See you next time.